How do I solve a system of equations by graphing? So today is the graphing day, which is great because you guys already know how to graph. Hopefully that warm-up jogged your memory. Please write this down. Equations. Know how to solve something like this. And we'll do this more tomorrow. Like if I put up x minus 2 equals 5, you know how to solve that equation. You'd add 2 and you get x equals 7. So that's the solution to that equation. Do you agree? That's the answer. Solution is just a fancy word for answer. So that's the solution to that equation. But when we're talking about a system, we're talking about two equations at once. And so the solution is where x and y are the same for both. So it's where x and y are the same for both equations. We find the solution. The x and y is the same. Let's see. Find the point of intersection, which is just a fancy word for where the lines cross. So wherever the lines cross will be your answer. It's the point of intersection because that's where x and y are the same. We have three types of solutions. This should sound familiar. One solution. And that's going to be written as a point. What do you think another type is? No, there would be for, you're not completely wrong because if we had a quadratic, like a curvy line, then we would have two solutions actually. But we're going to deal with straight lines only. So the other ones will have our no solutions. You should remember that from solving equations. And remember this one, infinite solutions. It's coming back. No solutions, infinite solutions, one solution. We got two equations here, right? We got y equals 2x minus 4 and y equals negative 3x plus 6. If it helps you to write down the stuff like we've been writing it down, like 2x minus 4, well, my slope is 2 over 1, which is up or down? This is puff, puff, positive. Up 2, right 1. You can still write this down every time. I'm just not going to give you a spot to do it. And then the y-intercept is at negative 4. So let's go ahead and graph that. I'm going to graph this one in red. So I'm going to plot my y-intercept at negative 4. Go down 4. And then go up 2, right 1. All the way as far as I can go. And reverse it. You should get a straight line. Because we're dealing with linear functions. Does that look right?
Yeah.
Okay. The next one is y equals negative 3x plus 6. My slope, what happens over and over, is negative 3. Make it to fraction. Put it over 1. Brandy, is that going to go up or down? Down 3. And slope dude always skis to the right. And our y-intercept, the number by itself is 6, so that's my y-intercept. So I graph the point 0, 6. And then from there I go down 3, right 1. It should be a nice negative right line. connect the dots because it's not a scatter plot. Check it, make sure it's nice negative. At this point, whoop, 2, 0, right? Because that's where x and y are the same. They both have the same x and y at that spot, and so that is a solution. So if you were to plug in x2 and 0 into the equations, it would work for both. So our solution is the point 2, 0. It has one solution. Yeah. They have different slopes, which is what causes them to have one solution because they're turned different ways. But the y-intercept does not matter. I need you to write that down because eventually I'm just going to give you equations. You got to tell me how many solutions it has. So the y-intercept can be the same, but the slopes have to be different. That way they cross that one spot. So the slope is 2 over 1. That would go up 2, right 1. And the y-intercept is -4.
So if they don't meet, would it be no solution?
Exactly. Nice job. There's my first line. Make sure that it's going up to right 1.
No solution.
And then the next one, again, has a slope of 2 over 1. So up to right 1 and a starting point of 3 on the y-axis. So go to +3 on the y-axis and go up to right 1.
And they're both positive. The slope is both positive. Yeah. We'll even do this.
Don't cross, it's no solutions because they don't have the same x and y ever because they never cross. Okay, this is the important part. Things that we notice, important things to notice. I heard some really good stuff. William, what do you think? They are parallel. Ooh, they're parallel lines. Let's think about why they're parallel lines because that's what's parallel lines is what's causing this, but I want to know what's causing the parallel lines. What's making them parallel? Zach?
They have the same slope.
They do have the same slope. Okay. What's different, though? What's causing them? Because it's same slope, but what's different, Jack?
Y-intercept.
Different y-intercept. Brilliant. So because they have the same slope, intercept. But different y-intercepts, they will never cross, and because they're parallel, and so they'll have no solutions. No solutions. So I'm looking at this one. Line A has a slope of -3 over 1, which it goes down 3.
Oh, snap.
And right 1. And it has a starting point of 0, 1. Starting point at 1 on the y-axis and go down 3, right 1. Up 3, left 1. On the math test, you're going to have some graph paper, and so you can always graph if you feel like that would help. Whoop. Okay. Okay, let's look at the next equation. Y equals 6 divided by -2, x plus 1. Guys, what's 6 divided by -2? -3. Oh my gosh. It's the same equation. It's just disguised. Do you really think you need to graph that again?
No.
Not really. You could retrace the line if you want. So like, I might just go back over it because it's the same exact equation. It's going to have the same exact graph. Oh, whoops. Bad. I want to graph the line. So they're crossing like this. You have two of the exact same line. So what should I say? Zachary? Infinite solutions, because it's always crossing. It's always at the same spot. They always have the same x and y. Okay, so same slope and the same y-intercept. Yeah, great. So everything is the same. And because of that, you get two of the same exact line, and they cross all the time, and so it's infinite solutions. What we're going to do for this last section is just by looking at the slopes and the y-intercepts, we're going to decide, we're going to decide how many solutions it has. One, none, or no solutions, or infinite solutions, okay? So look at A. Their slopes are 9 and 2. And their y-intercepts are -5 and 5. Okay, if our slopes are different, how many solutions do we have? 1. Slopes are different. So we're not saying what the answer is, I'm just asking how many. So because the slopes are different, one solution. Look at the next one, B. Y equals -3x plus 2, y equals -3x minus 2. Slopes are the same, y-intercepts are different. Janaya? Right, because what are they going to look like? Parallel lines, so no solutions.
What?
Because they are parallel lines because they have different y-intercepts but the same slope. Next one, y equals 3/4 x plus 2, y equals 0.75x plus 2. Someone raise your hand, tell me, what do you think? 1, no solutions, or infinite solutions?
Infinite.
Raise your hand. Juwan?
Infinite solution.
How do you know?
Because 0.75 is 3/4.
Great. It's the exact same thing. Infinite solutions. Okay, let's go to D. Y equals 5x minus 4 and y equals -5x minus 4. Slopes are the same. No, slopes are different because 5 and -5 are not the same, but the y-intercepts are the same. What do you think? Right, one solution, because the slopes are different, right? And so one is puff positive, one's nice negative, so they're going to cross. Okay, this last one's kind of weird. Okay, remember, horizontal lines have a slope of 0, and our y equals a number. So these both have a slope of 0. They both have a slope of 0. You could rewrite this as y equals 0x plus 8 and y equals 0x plus 10. What is it, Elise?
No solution.
How do you know?
Because the slopes are the same if the y-intercepts are different.
Right. No solutions. These are going to be parallel horizontal lines. Sorry, guys. E. Okay, one more thing because I forgot. What number is in front of x right here? 1. Y equals 1x minus 2, y equals 1x plus 5. Think about what it would look like. What's the same? What's different? Slopes are the same. Y-intercepts are different. So what's it going to be, Sebastian?
1.
So because of that, how many solutions, Sebastian? They're going to be parallel lines. So how many solutions we have? Nope.
No.
No solutions. There we go. They'll never cross.